Covalent bond or molecular bond. We know that a bond formation between two atoms takes place by losing, gaining, or sharing of electrons. The chemical bond formed between two nonmetallic elements, having same or different electronegativities by the mutual sharing of one or more electrons, is called a covalent or a molecular bond. But what is electronegativity? The nucleus of an atom possesses positive charge. Sometimes there is an effective positive electric charge of the atomic nucleus beyond the valence shell. Therefore, there is a force of attraction acting on the shared pair of electrons of the covalent bond. Such a type of attractive force exerted by the nucleus of an atom is called electronegativity. Or we can also say that electronegativity is the relative electron attracting power of an atom. The following table shows the electronegativity values of various elements. It is important to note here that the type of bond formed is largely determined by the difference in electronegativities between the atoms involved. Atoms with similar electronegativities share an electron with each other and form a covalent bond. Furthermore, if the bond is formed between atoms with little difference in electronegativities, then the electronegative atom pulls the bonded electron pair slightly stronger than the other atom, and a polar covalent bond is formed. However, if the difference between electronegativities is too large, then the electron will be permanently transferred to one atom and an ionic bond will be formed. Now, let us understand the covalent bond formation by taking the example of two chlorine atoms. Here, both the atoms have similar electronegativities, and both of them are deficient in electrons. As both the atoms have the tendency to gain the electrons, transfer of electron is not possible, and the sharing of electrons satisfies the octet. This type of bond formed is called a covalent bond. Here, the number of electrons of one atom forming a shared pair with another atom is called the covalency of that atom. Thus, both the chlorine atoms share a single pair of electrons to form a single covalent bond. Hence, its covalence is 1. In the oxygen molecule, each oxygen atom has 6 electrons in its outermost shell. It needs 2 electrons to attain neon-like configuration 2,8. Hence, 2 oxygen atoms combine by sharing 2 pair of electrons, forming covalent bonds. Thus, the covalency here is 2. In the case of water molecule, oxygen shares 2 electrons with 2 different hydrogen atoms. Hence, covalency of oxygen here is also 2. In compounds like nitrogen N2, ammonia NH3, etc., covalency of nitrogen is 3.
بنلاقي هنا ان احنا لو اتحركنا
covalent bond or molecular
بعيد عن الصورة اللي هي المفترض تعتبر
covalent bond or molecular